Have you ever wondered how to measure the length or magnitude of a vector? That's where the norm of a vector comes in. The norm of a vector is simply its length or magnitude. So think of the norm of a vector as the distance from the origin to the point where the vector ends. For instance, in two-dimensional space, we have a vector 4, 2. Its norm is the distance from the point, the origin here, 0, 0, to 4, 2, which is this one. So the most common norm, or the formula for the norm of a vector in n-dimensional space, is given by this. So let's consider VB a vector in Rn. So then we can represent the vector V using coordinates. So which is, let's say, x1, x2 up to xn. Then the norm of a vector, which is represented by this norm of V, which is given by the square root of x1 square plus x2 square plus xn square. So this is the formula for the norm of a vector. And we are assuming this vector, so the initial point of the vector is the origin. So if you have 2 points, let's say P is having the coordinate x1 up to xn, and we have Q, which is given by y1 to yn. Then the norm of the vector PQ, which is given by the square root of y1 minus x1 square plus yn minus xn the whole square. So this is the standard formula to find the norm of a vector in n-dimensional space. For example, if you have 2 points P in 3D, let's say 1, 2, 0, and Q is given by 2, 0, minus 1, then the norm of the vector PQ is the square root of 2 minus 1 the whole square plus 0 minus 2 the whole square plus minus 1 minus 0 the whole square, which is the square root of 1 plus 4 plus 1, which is square root of 6. So geometrically, the norm is the hypotenuse of a right angle triangle formed by the vector's components. So this is why the formula looks like the Pythagorean theorem. So for instance, if you look at the points in 2D, so let's see this point here. Let's see the point, we have point P and we have another point Q. So this is, we can draw a line parallel to the x-axis, and we have a line parallel to the y-axis, so they make a right angle triangle. So the norm is this one, so which is the hypotenuse of a right angle triangle. So computing the norm is useful everywhere. So for instance, in machine learning, they are used to measure the distance between data points, and in physics they calculate the forces and velocities, and in computer graphics they determine the object size and position. So in general, the formula for the norm of a vector is given by this one, and whatever you have points, whether the initial point is 0, 0 or something, you can apply this formula to find the norm, which is norm of V. Thank you for watching.